right, welcome everybody to the CompTIA CYSA Domain 1 Final Review CRAM cohort. So what we're going to focus on today is primarily Domain 1. And this cohort is designed for anyone who has done all the studying, feels like they're ready for the exam, and just needs that last minute highlights in order to get yourself across the finish line. So I'm Steve Putnam, and I'll be an instructor today. And let's take a look at some of the key concepts of CYSA and understand what we're dealing with. So essentially, we're going to detect and analyze indicators of malicious activity, understand threat hunting and threat intelligence concepts, use appropriate tools and methods to manage, prioritize, and respond to attacks and vulnerabilities, perform incident response processes, and understand reporting, communication concepts related to vulnerability management and incident response activities. So let's look at the exam itself. There's your exam code there at the top. That's the one you should be taking. You're going to get a maximum of 85 questions, depending on how you do, since it is adaptive. You're going to have both multiple choice and performance-based questions. Remember now, the performance-based questions are extremely important. They can be weighted much higher than the multiple choice, and you will get those probably the first 5 or 6 of the exam will be performance-based questions. So we'll get into kind of how to navigate those later. You'll have 165 minutes to pass the exam, and you need a passing score of 750 out of 900. CompTIA suggests 4 years of hands-on experience with a Security Plus and a Network Plus certification, or the knowledge of those certifications to pass the exam. So here are the domains that the CYSA focuses on. Domain 1 is what we are going to focus on today. And that is security operations, which is 33% of the exam. Domain 2, vulnerability management. Domain 3, incident response management, and then reporting and communication. All right, so let's take a look at Domain 1. All right, I don't know why that's there. Let me delete that. All right, so explain the importance of system and network architecture. So let's get into that. First thing to look at is log ingestion. Okay, what's log ingestion and why is it so important? Well, it's a critical process in security operations, as you can see from the slide here, where data from various systems, devices, and applications are collected and centralized. So generated by all connected devices on your network. Standardization or conversion is essential to the log formats and ingesting those, as well as storage and retention. That is based upon the compliance framework that you or your company is subjected to, whether it be HITRUST, SOC 2, NIST, or any of the other ones. So logs are generated by every device within your organization's network. That's like servers, firewalls, routers, workstations. Any of those things create a record of the activity in a log file. These log files are then ingested to a central location. And generally that is a SIEM tool, security information and event management tool. You can ingest it in other ways, but that is the most efficient way from a cybersecurity perspective, because the SIEM tool itself allows cybersecurity analysts to see all the logs in one place rather than having to go and check every individual device. So they're able to, look if something had been compromised, or during the investigation, have all those logs in one place instead of having to go to every device, which would take forever. This is crucial for incident response because log ingestion allows these analysts to detect patterns, and the SIEM tool does that for them. So it looks at the logs that are being ingested, and based off behavioral or signature techniques, it's able to highlight a pattern that may be happening where there's suspicious or malicious activity, and can alert the analyst to that, so that they can stop that attack. All right. Next thing that's important is time synchronization. All right. So if you think about this for a minute, if every device had a different time, then how would an investigation be accurate? You would not be able to build a reliable timeline of the incident if everything had a different time. So the network time protocol, which is essentially what you sync all your devices to one time, ensures that you're able to look at the different events that occurred and not synchronize, I should say, but to correlate those. So you can look at, when an attacker may have breached the network, how long they were there, things of that nature. So we have to make sense, as this slide says, of what occurred, when did the attacker get in, um, how long were they in the network, and then look at what they actually did in the network. So all of these are extremely important. So you're to building the timeline. So time synchronization is just as important as your log ingesting. Now let's get into logging levels. Okay, what are the importance of logging levels? Well, we have several here. It's the amount of detail captured in log entries, but there's several examples here of the types of levels that we could have, whether it be error, warning, info, debug, and trace. And we're going to kind of go through those and discuss what each one of those is. But logging levels help categorize and prioritize system messages based on their severity and purpose. All right, so the proper use of logging levels allows for efficient monitoring and troubleshooting. So let's look at these logging levels. Error, for example, indicates a serious issue that prevents functionality, either a service crash, a failed database connection, a failed server, a failed application. Anything like that is what error logging level refers to, and it requires immediate attention to restore normal operations. All right, warnings. That's exactly as it says. Signals a potential problem or unusual behavior. So there's something going on out there that the system hasn't seen before or is not usual, and it alerts you to a warning that something may not be right. Not necessarily always critical, but it's something that should be monitored before it escalates. All right. Info, informational. This provides general information about system events. Logon, successful transactions, unsuccessful transactions, unsuccessful logon. These are very important to kind of correlate with the errors or the warnings in order to be able to say, okay, what else was going on in the network during this time? Debug. This is primarily used by developers, but it's troubleshooting for like function calls, variable states. It's typically used during the development or testing phases, and it's not normally turned on, all the time. Trace. It's the most granular level of logging level, capturing step-by-step execution details used for deep diagnostics and identical intricate issues. So that gets really deep into it. Okay. Example levels. So here's some examples of what these may look like, just to kind of give you an idea. Um, you know, for example, an error failed to connect to a database. Your warning could be that your disk usage is too high on your C drive. An info could be, an admin logged on successfully at 10:45, but maybe you didn't have any admins at work at that time. Maybe somebody was elevating with an admin, right? Um, Debug again, validating user input. Uh, again, very much about debugging applications and software development. Okay, so why does logging matter? Let's kind of look at that. What's so important about logging? Well, again, there's three things here: efficiency, focus, and cost management. We'll kind of go through that. So logging improves operational efficiency. It provides detailed insights into system activities, allowing IT teams to quickly identify and resolve issues. Centralized logging helps streamline monitoring, as we talked about earlier, by consolidating these logs and the data from various sources all over the network into a single location that can be analyzed. Automation tools can analyze logs to detect anomalies. As I said with the SIM, it can detect any anomalies in real time and reduce that manual effort. Okay. Focus on critical issues. It enhances focus on critical issues. Prioritize logging levels, i.e., error, warning, info. Help teams focus on high impact problems first so they can prioritize what they're doing. Alerts generated from critical logs allow swift action, minimizing downtime and disruption. And logging also enables trend analysis, helping identify recurring issues and vulnerabilities that require attention. And of course, it supports cost management. Proactive monitoring through logs, it reduces the likelihood of costly downtime or service interruptions. By detecting potential failures early, that helps avoid expensive emergency repairs. Optimize resource usage, such as identifying underutilized or overburdened servers, and it helps reduce operational costs. Okay, so that's why logging matters. Operating system concepts. All right, so operating systems, OS, form the backbone of every computer system. That is the applic or the, I'm sorry, the operating system manages all the hardware, runs the computer system, it runs all the applications, and facilitates communication between all the different parts of the system and the hardware as well. So in security operations, understanding OS concepts is literally vital, okay, to protecting a system from potential threats. How the OS works, how it can be exploited, what the vulnerabilities are, and remediating those vulnerabilities. So understanding the operating system you're working on is absolutely critical. So for Windows, for example, Windows Registry is your best friend. It's a database that stores configuration settings and options for the Windows OS. It's a blueprint of how the operating system operates. So if you look at the registry, you can tell this is how Windows works. And essentially, once you understand that, you can understand how it can be exploited and how it can be protected. So why does the CYSA Plus care about the Windows registry? Well, persistent mechanisms, configuration changes, forensic analysis, they use the Windows registry for all of this. So in terms of persistent mechanisms, attackers often use the registry to make malicious software persistent. What this really means is the malware will automatically run whenever the system starts, even after a reboot. Understanding where and how those attackers modify the registry helps you as an analyst detect and remove those threats. Okay. In terms of configuration changes, misconfigurations in the registry can weaken the system security. So, sometimes when you scan, you find vulnerabilities and there's a patch for it. That is not always the be all end all. Sometimes you have to harden the system manually. In the DoD, they call it stigging, where you're essentially there are settings within the registry and the configuration management as a whole that you have to set to ensure that the system is hardened. And then forensic analysis. The registry provides all the information about the system usage. It can show you what programs were executed, what users were logged in and out at the time, what devices were connected, everything. And so it's invaluable when investigating an incident to understand what the attacker was doing. Um, so the key areas to monitor in the Windows registry, when you're doing incident response or proactively monitoring a Windows system, there are certain areas of the registry that you should focus on that are likely to be more attacked by hackers. Okay, and some of those are, your startup programs. They often, attackers often add entries here to ensure that malware runs every time the system starts, as we talked about before about persistence. Monitoring this key can help detect those persistent mechanisms. Excuse me. Services. Malicious software can be, disguised as legitimate services. They can spoof them, or they can, they can add to that key and run with elevated privileges. So regular checks in this area can reveal unauthorized or suspicious services. User preferences. This key stores information about recently accessed files, which can be useful in determining what files an attacker interacted with. Browser settings. Attackers use, they modify browser settings to redirect traffic to them or disable security features or install malicious add-ons. Monitoring the browser-related keys is important to detect that kind of thing. And then, you have your shell commands. Attackers may modify the shell to execute malicious commands during system startup. So you want to make sure that those remain secure as well. And again, attackers will leave, all of these footprints, or can leave all of these footprints in the registry for you to find. So, but the CYSA exam places significant emphasis on incident response and forensics investigation. So, understanding the registry is crucial because it provides the evidence needed to respond to, report on these security incidents. And that's going to be directly, related to the questions in the exam. In many cases, attackers will try to cover their tracks. They'll erase things. They'll do whatever they can to ensure no one knew they were there. But the changes in the registry are really hard to hide. And if you know how to analyze the registry, it'll allow you to really take a look at where they were and what they were doing and prevent future attacks. All right, system hardening. This is what we were talking about. And this is uh, it's securing a system to reduce potential vulnerabilities. Now, we did discuss in an earlier slide about manually setting the configuration to harden the system, but of course there is patches, remediation of vulnerabilities that are put out by the vendors that attempt to do this, but there are still some that you have to do manually. But why do you even do system hardening? What is the point of that? To close unused ports, those kind of things. Well, it reduces your attack surface. So essentially, if a port is open that shouldn't be open, that you're not using for anything, why have it open? That just increases your attack surface, and allows a bad actor to use that port to get in. Mitigating known vulnerabilities. Again, if you do a Nessus scan or an OpenVAS scan and you find vulnerabilities in your system, Windows needs to be updated or an application needs to be updated to close those vulnerabilities. That's how you would mitigate some of those. Compliance and best practices. So, again, let's go back to those frameworks, HITRUST, SOC 2, NIST particularly. They provide best practice and recommendations to be both compliant with the framework, but also, to ensure that your system is secure. All right, so that's important. And enhanced detection and response. We've kind of beat that to death, but when you harden something, it's easier to monitor because you've reduced what you need to monitor because you've already hardened it. And you can look for that unusual behavior, something will stand out. All right, there's several steps in hardening. Let's take a look at those. So, you have your patching and updating as we talked about, disabling unnecessary services and ports, enforcing strong authentication and authorization, enable logging and monitoring, configuring firewalls, system integrity checks. All of these things are part of hardening the system. Some of them can be done with patches. Some of them can be done, with a script. But sometimes you may have to do it manually, and change the entire configuration baseline. Let's look at the Windows file structure here. So the Windows file structure is organized in hierarchy. It starts with the root directory, typically denoted as C on the primary drive. Each drive or partition is assigned a unique letter, like D or E. Key system folders include, C Windows, which holds all the OS files, C program files. That's where all your installed software is. C users, where the user profiles are and personal data is stored. And then, of course, there's hidden folders. The recycle bin, the system volume, all of these contain metadata or temporary files. But it's essential for a CYSA professional to understand how to navigate and analyze these structures, particularly when investigating for malicious activity. This includes monitoring critical systems, folders for unauthorized changes, checking hidden directories for malware, and analyzing user profiles for signs of data exfiltration. In Linux, it's a little different, but same concept. The Linux file structure is organized as a hierarchy as well in a tree format, starting with the root directory. Then you have key directories like bin, which contains your essential binaries like system commands, your etc or etc for configuration files, and your home where your user data and profiles are stored. Critical system files are located in the boot directory and the var for logs and variable data. And the user directory holds all the user installed software, while temp is used for temporary files. Hidden files and directories typically prefixed, with a dot. They're common. They're common in Linux, especially in the user home directories. They often contain configuration or application data. So for CYSA professionals, understanding the Linux file structure is critical for detecting anomalies, such as unauthorized changes in the etc, unusual activity in the temp, or hidden files in the home. Regularly monitoring the logs in varlog and investigating, suspicious binaries of script. That's really important for system security and forensics analysis. All right, so system processes. Let's talk about those. What are system processes? Well, as you can see here, active programs and services running on the system. This includes system level tasks, or user-initiated applications managed by operating system through the kernel. Key types of processes include system processes, user processes, background processes. There's a lot more, but these are key. You know, and those are the ones that you want to pay attention to. So what are the takeaways here from what we just discussed? You know, how does that relate? What is the importance? So importance to CYSA professionals, the monitoring process is vital for identifying unusual or unauthorized activities. Suspicious processes that could indicate malware, crypto miners, remote access tools, various things. You know, high CPU usage or memory usage that's unusual, you know, usage by a single process, that could be a red flag. You know, your tools for process analysis, you know, on Windows, you would use Task Manager, PowerShell, things like that. You know, on Linux, tools like HTOP, systemctl, you know, they provide insights into active processes and resource usage. Red flags in the process. You know, this is the kind of stuff you would look for that should alert you something's going on. So unfamiliar, misspelled process names. You know, processes running, um, you know, from unfamiliar areas or locations or directories. Processes using unusual ports for network communication. You know, like so for RDP, it's 3389. You know, what if the RDP is saying it's running 3391? Well, that would have had to have been changed. So something's weird there. And then of course, unauthorized processes added to the system startup. But your key monitoring things here would be, you know, continuously track this. You know, anything with high resource usage, unusual activity, this is what you need to be tracking. And you can compare the running processes against the baseline that you've created to identify those anomalies. Okay, so a practical example of all this is a process like servicehost.exe is legitimate, but what if you found it running from a non-standard directory? That could be a sign of malware. So those are the key takeaways we're trying to look at here. So let's look at our hardware architecture. Hardware architecture, the foundational design and structure of physical components in a computing environment. This includes computing devices, storage, networking, peripherals, lots of risks with hardware. It's not just software that's at risk. Hardware can be hacked. So you've got hardware trojans, firmware attacks, physical tampering, actual physical tampering. Um, monitoring, you know, you monitor your hardware resource utilization to detect those anomalies. You know, and you can identify unauthorized hardware connections such as rough access points, right? So some examples, you know, if your CPU, you know, if it's pegged, you know, and it shouldn't be based on the current workload of the user, what's going on there? Same thing with RAM. If your RAM is pegged out, what's, you know, who is leveraging that to to fire off a process or something like that, or make communication. All of those things are critical, uh, you know, to monitor. Let's look at your security hardware specifically. So this is a list. I'm not going to go through every one of them, but this is a list essentially of all the security hardware uh, that monitors or you should be monitoring or is part of security in a network. You know, things like firewalls, IPS, IDS, your DLP, your VPN, your endpoint detection and response software. All of these things are critical. And, you know, when you get into this, you can look at the definitions of each one of these and see how they interact and intertwine with each other to help protect the network. So our infrastructure concepts, let's take a look at that. So the CYSA exam specifically covers serverless, virtualization, and containerization. And for those of you know, at this point in your studies, you should have already gotten to this point, but I'm going to go ahead and define these to make sure we're just saying it out loud so you can remember them again after the cohort. But the definition is of serverless computing. Okay, essentially it's a cloud computing model where developers run code without managing servers. So there's no server managing that application or that code. It's run without servers. The cloud provider handles all server provisioning, scaling, and maintenance. So any CPU memory needed to run those that code is handled by the cloud provider. So some key features there. It's event driven. It executes code in response to triggers, HTTP requests, database updates, anything like that. And it's usually a pay-as-you-go model. So examples of these are Azure functions, AWS, um, Lambda, or Google Cloud Foundations, right? Virtualization, the definition of that is the creation of virtual instances of hardware resources, either servers, storage, networks, using hypervisor software that mimics, it creates a virtual version of your server or your storage device or your network device. It allows multiple virtual machines to run on a single physical machine. So each VM is isolated, operates independently with its own OS and applications, and the hypervisor, whether it's VMware, ESXi or Hyper-V, that manages those virtual resources and the access to the hardware. It acts as a layer in between your applications, operating system, and the actual hardware that manages all those VMs. So this maximizes resource utilization. You can run multiple workloads on a single hardware device. It simplifies disaster recovery, etc. Now, containerization is a little different. It's a lightweight virtualization method. It packages an application, for example, and all of its dependencies into a single unit called a container. Now, they still do have virtual applications, but containerization is much lighter. So the containers share an OS kernel, but they run in an isolated environment. So, for example, if you could technically run an application that is not compatible with Windows 11 within the Windows within the Windows 11 environment because it can share the kernel, but it would have its own dependencies, its own OS within the container and be able to run that. All right. So it allows, the containers, they're portable. They can run across multiple different environments. And they consume fewer resources compared to VMs. All right. So let's take a look at our network architecture. I kind of skipped over some of those because we went through them already. But your network architecture can be on-prem, it can be in the cloud, it can be a hybrid of both in the cloud or on-prem, zero trust. I mean, all these different things. Network architecture is essentially uh, the the design and structure of your network. So it encompasses the hardware, the software, the protocols, the policies. A robust architecture ensures security, scalability, and efficiency in data communication. So let's look at each one of these in a little more depth. So an on-premise network architecture. This is traditional. All the hardware, software, data, everything is hosted and managed within the organization's physical infrastructure. Nothing in the cloud, nothing on, it's all managed internally. Now, there's some good parts of that, and there's some bad parts of that. Obviously, one of the good parts is that you have full control of this. The company owns and manages all the components. So you're responsible for security, you're responsible for operations. That's good. You've got data sovereignty. Ensure sensitive data stays under direct control. You never have to worry about whether your data is being leaked. Um, it's customizable. Generally, it's the best suited for strict regulatory environments such as NIST. There are some challenges. I mean, there's a high upfront cost, significant investment in hardware, software, skilled IT personnel to manage it and secure it. That you have an issue with scalability. If you want to grow, that requires purchasing more hardware and integrating it and configuring it into your current network. All of these things, matter. It's resource intensive. Ongoing management, the monitoring, the troubleshooting, all the internal teams having to deal with it. That is all, critical to understanding what type of network infrastructure you should have. If we look at the cloud in comparison, right? So the cloud, it's network infrastructure hosted and managed by third-party cloud service providers like Azure, AWS. It enables on-demand access to resources like storage, servers, and applications. So It's very elastic. You can grow and subtract based on your current workload or your need. And it's very simple to spin up another server or another virtual machine or another network device. And generally, it's pay as you go. So you only pay for what you consume. So in the on-premise model, if I have to go buy another server for a major project and pay for that and get it integrated, and then oops, all of a sudden, now I don't need that anymore. Well, I still own that server. I still have to pay for it. This is pay as you go, so you don't have to deal with, um, you know, the ongoing maintenance cost of something you had to buy. And it's globally, excuse me, globally accessible. You can reach it from anywhere. You can reach your entire infrastructure from anywhere. So that's great. Now your hybrid model is very eclectic and it's agile, meaning that you have a combination of on-prem and cloud. So this allows organizations to have their physical infrastructure and their cloud resources. So what that allows you to do is to be flexible. You still have control of your data. And if you do have to grow for major projects or a surge, you can extend your environment into the cloud, pay for it for that period of time, and then bring it back home. So a lot of companies do run a hybrid version of their network architecture. Network segmentation. What is network segmentation? Well, it's the practice of dividing a network into smaller, isolated segments to improve performance, security, control over traffic flow. The features of it are traffic isolation, access control, and enhanced security. So the importance, it limits lateral movement of attackers within a network. If you segment your network from a user VLAN to a server VLAN to and you make sure that all of those resources are segmented. If an attacker is able to gain access to say to the user VLAN, they will likely not they will have a very difficult time moving on over to the server VLAN. And that allows you to identify them early, through those anomalies and the logging and everything else we talked about. You can find their behavior before they have a chance to move laterally into more critical infrastructure. So you do have a couple ways of doing this. There's different types of network segmentation. All right, you have physical, logical, and microsegmentation. So physical is exactly how it sounds. It uses separate physical hardware for each network segment. It's not fun. Again, it goes back to the cost, the maintenance, the hardware. But then there's logical segmentation, which is achieved through VLANs, subnets, firewalls, separating traffic without additional hardware. This is the most used method to segment your network because it doesn't cost additional hardware. It's essentially done in a software environment. Microsegmentation. This is finely grained segmentation down to individual applications or workloads, all the way down to, we only run this application in this segment or this application over here. That gets very time consuming, but it's used the most in a cloud environment because the cloud is so flexible. You can look at microsegmentation, which is extremely secure. And it allows a lot of control over what a user has access to, and that rolls right into our next conversation about zero trust, because that is essentially the goal of zero trust. It's a security framework where everyone and everything trying to access any network resource, whether inside or outside the organization, has to be authenticated, authorized, and continuously validated. What does that mean? Well, essentially, again, if we go back to looking at network segmentation and how it rolls into zero trust is never trust anyone, always verify. So traditionally, networks were designed with a strong perimeter defense. Anyone inside the network could pretty much do whatever they wanted because they were trusted until you got into role-based access control. But essentially, once they were in, they were trusted. In you know that is a vulnerable model to attacks. that occur from within the network, such as insider threats and those that exploit weak points in the perimeter defenses. Zero trust assumes that the threats can exist both inside and outside the network. And as a result, trust is never given by default. So if you're trying to access an application, it continuously verifies that you have access to that application and that you're authorized for that application and that you have access to that segment of the network. Again, remember we went back to micro-segmentation. Everything is segmented within a zero trust model. It relies on more granular context-based approach to security. So access to resources is granted based on user's identity, device health, specified resource they're trying to access, how long it's been since they've been on the network. There is just a plethora of things that can be leveraged to validate that user's access to any of the resources on the network. All right, so this is kind of an overview of zero trust. There's a lot more to it, obviously, but it verifies explicitity, least privilege access, micro segmentation, as we talked about, continuous monitoring and validation, and it always assumes it's a breach. So when it comes to verify explicitity, I have a hard time saying that word. Every access request should be verified, whether it's coming from inside the network, outside the network. It's all going to be MFA, multi-factor authentication. It's going to identify, it's going to verify your identity. It's going to validate the device. Simply being on the network does not get you access to anything in a zero trust model. It also looks at least privilege. Users will only have access to the resources they absolutely need to perform their tasks. And that's where micro-segmentation comes in, is you can grant access for a certain period of time or to a certain resource, but if I grant you access to that particular application, it's not on there may not be other applications on that segment that you can get access to. It may just be that one application, which really limits you to what you can get to. I mean, it minimizes the potential damage an attacker can do with a compromised account. But in the zero trust model, RBAC is still used to enforce least privilege principles. And again, let's go back to microsegmentation. The network's divided into small segments, each one with its own access controls. This ensures that even one part of the network is compromised, attackers can't move laterally to the other segments. So it allows for tighter control over the data, the resources. It's really the most secure model out there. And then we have our continuous monitoring and validation by zero trust, where access isn't granted indefinitely. Zero trust, we continuously monitor the access. It's reevaluated based on real-time factors like changes in the user behavior, or device health. If the device isn't patched or the device has been moved or not granted access to certain segments, or the user is acting unusually, downloading files that he normally doesn't download, Zero Trust will lock him out of that resource. And Zero Trust operates under the assumption that a breach is either occurring or will occur. So it assumes at all times that a breach is possible. And this mindset leads to proactive security measures and minimizes the impact of a breach when it happens by assuming that the threats could exist anywhere. Security teams are better prepared to detect and respond to them in a zero trust model. All right, let's see what else we can look at here. We're going to go talk about SASE. All right. So what is that? What is Secure Access Service Edge? All right. It's cloud-based network architecture that combines wide area networking capabilities with comprehensive security functions delivered as a unified service. So it consolidates networking and security into a single platform. So it provides an organization with flexibility and scalability to secure remote workers, cloud applications, distributed networks efficiently. Now, in a traditional model, networking and security were handled by separate, often disjointed tools and services. Network security was enforced primarily at the perimeter. Not a lot going on internally. They did that with firewalls, IPSs, VPNs. However, with the rise of cloud and remote work, this perimeter has dissolved. It's just gone. There is no perimeter anymore because it's not on-prem. So you need a more integrated approach. Um, SASE brings together networking and security services into a single cloud delivered service model. So this makes it easier, to secure users, devices, and data across various locations. So what's the components? Let's look at that. So you have SD-WAN, which is software-defined wide area networking, cloud access security broker, secure web gateway, zero trust network access, firewall as a service, and data loss prevention. So each one of these, I'm going to go through each one of these definitions quickly so we can stay on the same page, but it's a wide range of security and network technologies in one framework, essentially. So SD-WAN, definition of that, essentially it allows organizations to create and manage secure, optimized connections between distributed sites, remote workers, cloud services. And of course, it does provide the flexibility by intelligently routing traffic over multiple network paths, MPLS, broadband, LTE, whichever way you're connecting. So cloud access security broker, what it does is it sits between the cloud service provider users and the cloud application. So it enforces security policies, monitors user activity, and protects sensitive data. It's essential for securing the use of cloud-based applications like Microsoft 365, Google Workspace, and Salesforce. The secure web gateway protects users from web-based threats. It filters malicious web traffic, enforcing acceptable use policies and blocking access to dangerous and inappropriate websites. We already talked about zero trust. We know what that does. Your firewall as a service. This is basically having a scalable firewall. Protection from cloud, inspecting traffic across all locations and devices without the need for traditional on-prem firewalls. And your DLP, well, just as it says, it's data loss prevention. So it monitors and controls data flows to prevent unauthorized access to leakage of sensitive information such as PII, intellectual property, financial records, all of those things. And all these components together, are delivered through the cloud, and they allow organizations to manage networking and security as an integrated service, which is the key here. Instead of just relying on patchwork of separate hardware, software, all these things that are stovepipe and don't integrate with each other. All right. So again, if we want to look at the software-defined networking, so software-defined networking has been around for a while, but it's particularly gained speed within the cloud environment. It's a modern approach to network management. It separates the control plane or the decision making from the data plane, the traffic forwarding. It centralizes network intelligence into a controller, and it enables dynamic configuration and real-time adjustments. So some of the key features here, centralized control, programmability, scalability, and network virtualization. Identity access and management. Identity and access management. All right. So all of these things underneath here are included in identity and access management. Multi-factor authentication, single sign-on, federation, privileged access management, passwordless, and cloud access security broker. So let's go through each one of these and take a hard look at what they are. So let me slide down here just a little bit. Let's go to MFA. All right, so what is MFA? It's a security mechanism that requires users to verify their identity, right? Again, MFA is critical to zero trust. It will be incorporated into zero trust, but it allows them to identify their identity using two or more factors. So I'm sure you've all heard this, something like a password or a PIN, something you have, a piece of hardware like a smart card or a smartphone or even a hardware token, and something you are, which is your fingerprints, facial recognition, any of those things, any biometrics. Okay, so the purpose of it is it enhances security by adding additional layers of verification beyond just a password. So it reduces the risk of unauthorized access, even if your password's compromised, for example. All right, single sign-on. It's an authentication method that allows users to log in once and gain access to multiple applications. So I'm sure, just in your daily lives, at your job, or even within WGU, we have single sign-on. So once you sign on to your corporation's systems, if they're leveraging single sign-on, then that single sign-on would be used to access everything that you are authorized to access, even in a zero trust environment. So it would continuously validate you, but you would be able to sign on just once. You would not have to sign. So, for example, you would have to sign on to the database and then go sign on to your email and then go sign on to, another application that your corporation is using. If they're leveraging single sign on, you sign on once, and whatever you are authorized access to, you can get access to. So this gives you an improved user experience, absolute enhanced security, efficiency, obviously, because you're not having to log on to 100 things at once, or different things across the day. And it has centralized management, so you can manage single sign-on from a centralized area. Federation. It's an authentication model that allows users to access multiple systems and services across different organizations. So this is kind of similar to single sign-on, except this deals with organizations. So cross-domain, cross-organizational access, and trust relationships. So what does that mean? Well, it establishes a trust between identity providers and service providers to enable secure cross-domain authentication. It works, a user authenticates with their home organization's, identity provider. So you would authorize to your company's identity provider, and if they have a federation or a trust between your organization and another organization, then that sign-on would be trusted, and then you would be able to have access to the other organization's access that you're authorized for, or the other organization's resources that you are authorized for. So that token from your IDP is trusted by the service provider, and then it grants user access to resources without re-authentication. Privilege access management. Privilege access management refers to the tools and processes used to secure, manage, and monitor privileged accounts. This is specific to admin accounts, elevated accounts within the organization. It prevents unauthorized access to sensitive data. It minimizes the attack surface by limiting privileged accounts, and it monitors and logs everything for that privileged account. So some of the key features of it, it's got credential vaulting, secured storage of privileged account credentials, reducing exposure to unauthorized users. It tracks and records privileged user sessions for auditing and monitoring. Access controls enforces least privilege by granting access only when necessary and for a limited time. It incorporates multi-factor authentication and adds that extra layer of security for privileged accounts. So PAM is specific to those privileged and elevated accounts, and it monitors all of those, so that if an attacker tries to elevate, we get alerted, and PAM shuts them down. So passwordless. Passwordless authentication replaces traditional passwords with more secure and user-friendly methods. Okay, so meaning you don't have to type your password in every time you log into your machine. You can use biometrics. You can use a hardware token. You can use a smart card pin. You know, push notifications. All of these, and I'm sure you've all experienced these, whether you're logging onto O365 or any of your corporation's resources or even WGU. You can leverage some of these passwordless technologies, which makes things more efficient and more secure. The cloud-based access security broker, it's a security tool or service that sits between an organization's users and cloud applications to enforce security, as we talked about. All right. So the purpose of it is visibility and control over all user activity. It enforces all security policies, and it helps the organization ensure cloud aligns with compliance. All right. Some of the key features here: the visibility is great. It tracks all that user activity and identifies any authorized cloud applications, any shadow IT. Um, Threat protections detects and mitigates malware, phishing attempts, things like that. It protects sensitive data with encryption, tokenization, and DLP policies. It enforces policies based on identity, device type, or geographic location. These are like conditional access policies that you might find in Azure. Encryption. We all know about encryption. Encryption is one of the most important parts of security, right? And so what, PKI, the public key infrastructure, creates key pairs, manages key pairs, revokes key pairs. PKI is a framework for creating, managing, and using digital certificates and public-private key pairs. It ensures authentication, encryption, and integrity in digital communications. The purpose of it is it enables secure communication and verification of identities in digital environments. It's commonly used for, securing websites, email, network traffic, things like that. So what's SSL? Well, it's a cryptographic protocol and it encrypts data between the client and the server. So when you go look at, websites that are secure, on your browser, any data transmitted between, a browser and a server, that's all done with SSL. The purpose of it is to secure that data and protect it against man-in-the-middle attacks, and ensures privacy and data integrity. All right, public and private keys. Asymmetric encryption. Asymmetric encryption, it's a cryptographic method that uses a pair of keys. You have a public key and a private key. So your public key is shared openly for encryption, and your private key is a secret for decryption. All right, so it ensures secure communication between two parties without the need to share, secret keys in advance. And so it works essentially by the sender encrypting data using the recipient's public key, and then the recipient decrypts that data using the private key. This ensures only the intended recipient can read the data, because if they don't have the private key, they can't decrypt it. Okay. So PKI and asymmetric encryption, how do they work together? Well, PKI relies on asymmetric encryption. It's the foundation of PKI for securing communications and verifying identity. So, for an example, a digital certificate includes a public key for encryption, and it uses a private key for signing. So, when you get issued by a certificate authority, a digital certificate, that verifies the public key belongs to a legitimate entity. That's how that works. So the benefits of PKI and asymmetric encryption, um, you know, essentially authentication, right? That's the first one. It verifies the identity of users, devices, or services. It secures the sensitive data during transmission because it's encrypted. And with non-repudiation, digital signatures ensure that the sender cannot deny sending the message. And it's scalable. Public keys can be shared widely without compromising security. All right, let's look at our PKI systems, the different PKI systems. So we have your certificate authority, which actually issues and validates the digital certificates, the registration authority that verifies the identity of certificate requesters. Digital certificates contain the public key and the information about the entity, and certificate revocation list. This lists invalid or revoked certificates, so you know if someone is using a revoked certificate. TLS and SSL. Okay, so SSL is Secure Sockets Layer, cryptographic protocol designed to secure communication over the internet. TLS, which is the transport layer security, the modern, more secure successor to SSL, provides encryption, authentication, and data integrity. So some of the key features of both SSL and TLS, again, it secures the data during transmission to prevent eavesdropping, verifies the identity of the communicating parties using the certificate, and ensure the data has not been tampered with. So it ensures integrity of the data during transmission. Now, the handshake process is pretty easy. It establishes a secure connection between the client and the server. It uses asymmetric encryption to exchange the keys securely. It also provides session encryption. So once the keys are exchanged, symmetric encryption secures data for faster performance. Certificate verification. So the server presents a digital certificate to prove its identity. So that allows for all of that. But it does, SSL and TLS, and primarily TLS now, protects sensitive data, encrypts passwords, credit card details, personal information, prevents man-in-the-middle attacks, and secures websites and builds user trust. It's commonly used, these cryptography methods are commonly used within websites, email servers, VPNs, and APIs. So, sensitive data protection. What is sensitive data protection? Practice of safeguarding critical information such as PII and card holder data from unauthorized access, misuse, or breaches. Some of the key components is DLP, PII, and CHD. All right. So best practices for protecting sensitive data, if you implement DLP, as we talked about here, you monitor and control data transfers to prevent leaks, encrypting sensitive data, use a strong encryption method for PII and CHD, access control, limit data access to authorized personnel only, do regular audits on it, training for your users. But really, the relevancy to cybersecurity is protecting sensitive data reduces the risk of data breaches and regulatory noncompliance and ensures trust with customers and stakeholders by safeguarding their information. So, given a scenario, analyze indicators of potential malicious activity. So, normally in the live cohort, we will talk about this, but we can kind of move on to the next scenario, and I will post the questions and answers with the recording. But if we look through these slides, let's look at some of the potential malicious activity and how we can look at it. So, network-related IOC, indicator of compromise. So some of the things that you'll notice, when you're looking at an indicator of potential malicious activity, would be bandwidth consumption, unexplained bandwidth consumption, beaconing, irregular peer-to-peer communication, rogue devices on the network that you found, a tool that's scanning your network that you didn't kick off or that no one in the organization kicked off, unusual traffic spikes or activity on unexpected ports, as we talked about before, right? So, for example, unused bandwidth consumption, that's a sudden unexplained spike in network traffic. Could indicate maybe data exfiltration, where the attacker is transferring information out of the network. It could also be, a sign of a DDoS, distributed denial of service attack, or malware communicating with external services. Those unexpected outbound connections. I mean, think about that. It's network traffic. It could be an outbound connection to an unfamiliar or suspicious IP that you normally don't communicate with, maybe in a geographic location that you don't do business in. This is particularly, relevant for detecting command and control communication, where compromised devices are connecting to external services controlled by those attackers. Beaconing activity. That occurs when malware regularly communicates with an external server, maybe at consistent intervals. This could be a strong indicator that an endpoint has been compromised, is communicating with an attacker's infrastructure. This repetitive pattern can often be detected through, your SIM tool or NTA tools. So that's a good thing to keep an eye on. Suspicious port activity. Again, we went back to that. What if, you're seeing traffic over ports that is not authorized within your network, or don't normally see. So this could, be attackers trying to exploit vulnerabilities, move laterally across the network. All of that is important. Network detection. So how would you detect some of this? Well, you're going to detect it with, intrusion detection systems, intrusion prevention systems, network traffic and analysis tools, your SIM tool, packet capture, and threat intelligence feeds. All of these tools correlate together to help build the picture of what is happening and to determine whether it's a true positive or something else is going on within your network. So let's look at some of the host-related IOCs, indicators of compromise. So when you're at the host level, what can you look for? You can read this list here. Process consumption, memory consumption. We talked about a lot of this. Unauthorized software, malicious, processes, unauthorized changes, et cetera, et cetera. Data exfil. All of these will be indicators of compromise, something not going right. Very similar to network detection, but with different tools. Host detection. These are the products that you're going to use to detect those. A little different than network related, but you've got your endpoint detection and response, your EDR tool, your antivirus, your host-based intrusion detection, your file integrity monitoring, which we should be doing all of this, your SIM tool, and of course your logs. We talked about logs above. That helps you build that picture. Application related. Again, anonymous activity, introduction of new accounts that you didn't expect, unexpected output from the application, unexpected outbound communication. The application's talking to maybe a C2 server or something like that that you had no or should not be doing as advertised. Let's put it that way. The application has been, crashed, or there's a service interruption with that particular application. And then you can look at those application logs. Some other indicators of compromise. Of course, we have, social engineering attacks, things of that nature that you may not pick up as quickly from the tools that you use, because social engineering is exactly as it sounds, social engineering. But these are some other indicators of compromise that you should look at. So how do we, given a scenario, use appropriate tools or techniques to determine malicious activity? So what are some of the tools we're going to use? All right. Some of the tools that we would leverage, like again, packet capture, log analysis, endpoint security, sandboxing. If you find sandboxing in particular, if you find a malicious application or PowerShell script, you can actually, you bring that over to a virtual machine that is isolated and go ahead and run that application to see what it does, and then you'll understand the attack vector. Common techniques, pattern recognition, interpreting suspicious commands, looking at people's email that they may have received, analyzing those files that we just talked about, possibly sandboxing, and user behavior analysis. UBA tracks what, essentially. So if a user is normally online and works shift work from say 6 o'clock at night to 6 o'clock in the morning, but you have his user activity happening, at 10 o'clock in the morning or outside his normal working hours, and he's accessing applications that he normally wouldn't use, you would get alerted from the UBA telling you that this doesn't look right. This could be malicious or suspicious. Programming languages and scripting. The use of these languages and scripts are a good indicator of compromise. JSON, XML, Python, a lot of this PowerShell, a lot of it is written by attackers in those languages to deliver a payload. So like for JSON, for example, it's used to transfer data, one-to-many values. We would have to go into that further. I know it's in your reading specifically what they use it for, but particularly it's used to transfer data. XML, that's also used to transfer data, but you can look for that as well as a possible indicator of compromise on XML that you don't see or that's malformed or you haven't seen before. Python, it's used for logic scripting and programming, notice tabs, logic coding, all of those things. And again, seeing a Python script executed that is outside your normal library of applications or on a specific user or server, that is a really good indicator of compromise. PowerShell as well as Python. A lot of things, a lot of attackers are leveraging PowerShell, to build scripts and pull data. And of course, shell scripting been around for a while with Unix. Obviously, that's also used for scripting, and something to look out for. Some other things, expressions used for strings, okay, for testing. So let's compare and contrast threat intelligence and threat hunting. What is the difference? That's actually important. Threat actors. What? Threat actors. You've got advanced persistent threat, activists, organized crime, nation state attackers and threats, script kiddies, insider threats, and supply chain. So these are your different types of threat actors that you have to look out for. Um, so let's skip that over there. Confidence levels, you want to look at essentially, um, you want to look at timeliness, relevancy, accuracy. How sure are you that this is actual attack? What is going on? From the timeline perspective, does it line up with other indicators of compromise? That kind of thing. How accurate are your findings? You know, um, Collection methods and sources, open source, closed source. So your threat intelligence sharing, incident response, vulnerability management, risk management, security engineering, detecting and monitoring. Where threat hunting is looking at those IOCs, focus areas, active defense, and say like a honeypot. So when we explain the importance of efficiency and process improvement in security operations, um, you know, efficiency and process improvement is the two things that have to be always worked on. You always want to be efficient so that you can quickly catch an attacker, and make sure your processes are in place, for both threat hunting and threat intelligence, so that you can see improvement within your processes, procedures for the entire security operation or operations as a whole. And then you want to look at possibly automation and standardization. So you want to standardize those processes. You want to streamline operations, and you want to integrate all the technologies and tools you can, onto a single pane of glass, so that you can correlate the logs, the IOCs, everything that's happening into one area, so that your analysts are able to, identify a threat, investigate the threat, and remediate it. All right, so that is the end of domain one. This cohort, we have a cohort for domain 2, 3, and 4. So I look forward to all of you signing up for that.